Hello everyone, I'm Sebastian Y, and this is Principles of Macro. In this video, we're going to use Excel to look at historical data on the CPI and use that to calculate inflation rates. And then we're going to look at a few applications, including adjusting amounts of money for inflation and looking at regional price parities. I've aggregated all the data up to the annual level, starting in 1947 and then going all the way to the present day. In the previous set of videos, we used nominal and real GDP to calculate the GDP deflator and use that to calculate inflation rates. We're going to do that again, but we're also going to calculate it using the CPI and see how those two methods compare to each other. First, let's calculate our GDP deflator. Just like before, we calculate that by taking our nominal GDP divided by real GDP and then multiplying by 100. We're going to copy that formula all the way down, and if we scroll down through history, we can see here that the GDP deflator is 100 in 2017, which indicates 2017 is the base year when calculating real GDP. The first column in this data set is the CPI. Just like the deflator, the CPI also gives us a general idea of relative price levels through time. We can see that both of those measures are increasing throughout time. But unlike the deflator, there is no single year where the CPI is 100. So what's the base year here? Well, it turns out that the Bureau of Labor Statistics uses a combination of 1982, 1983, and 1984 as a collective base year. And so you can see that between the three of these, they're going to average out to about 100. Now let's calculate the inflation rates using our two price level indicators. So we're going to start with using the CPI. When we calculate inflation, we're going to take the current price level minus the previous price level, divide by the previous price level, and then multiply by 100 because we're converting it into a percent change. Notice that I did not calculate the inflation rate for 1947 because we don't know what happened in 1946. We can only start at the second year. I'm going to then copy that formula all the way down. And then I'm going to do the exact same thing with our deflator so that we can compare the two. We're going to take our price level in the current year minus the price level in the previous year, divide by the price level in the previous year, and then multiply by 100, exactly the same as what we do with the CPI, and then copy that all the way down. We can scroll down through history and compare the two, and you can see that they're generally pretty close to each other, but not the same. Generally, when inflation as calculated by the CPI is higher, so is the inflation calculated by the GDP deflator, but the numbers are a bit different. The differences arise from the fact that CPI is calculated based on the consumption that the average consumer does, whereas the deflator is based on total production in a country. Because the patterns of consumption are not necessarily going to be the same as the patterns of production, you're going to get some differences in these two measures. It's generally more common to use the inflation based on the CPI when it comes to thinking about consumers like you and me, because it's based directly on what we consume. Remember that when the inflation rate is positive, that tells us that prices are going up. And in general, most of the time that is the case. The higher the inflation rate, the faster the price level is increasing. If it's negative, which does occasionally happen, we have deflation, which means that the price level is going down. There is a third concept called disinflation that I brought up in the video on GDP data, which means that there's still inflation, but it's not as high as it used to be. And that's what we can see in these recent years of 2023 and 2024, where inflation is still positive, prices are still going up, but not as fast as they used to back in 2022 when the inflation rate was very high. I've put up on screen here a graph of the inflation rate over time. As you can see, both measures follow the same general patterns, although the inflation rate calculated by the CPI tends to be a bit more volatile. You can also see from this graph that the inflation rate almost never goes into the negatives, although it does happen occasionally. CPI is also useful if we want to compare amounts of money from different periods of time to each other. This is often called adjusting for inflation. In the Excel file, I've got the box office receipts of 4 James Bond movies ranging from 1964 to 2006. These figures here are in millions of contemporary year dollars, which means that Goldfinger's box office receipts were $124.9 million in 1964 dollars, While Live and Let Die's box office was $126.4 million in 1973 dollars. Since there was inflation between those 2 years, we can't directly compare those without converting them to the same year's dollars. The formula that we use can be used to convert the amounts of money to any year's dollars, but the most common thing is to convert them to the current year. We're going to need that, and then we're going to need the CPI from those individual years, 1964, 1973, 1995, and 2006. So I'm going to go back to our first tab here and find all 4 of those years. So 1964, the CPI is 31. I'm going to hold down Control while I do this. We're going to grab 1973. We're going to get 1995, and then 2006. Copy them, and then go back over to the box office sheet, and then paste those values into this new column, which I'll then label as CPI. Then I'm going to need the current year CPI, or as close as we have in this data set, which is 2024. I'm going to get that number. I'm just going to paste that somewhere over here. Then I'm going to make a new column for the box office in millions of 2024 dollars using our formula. So we're going to take the amount of money for Goldfinger, multiply it by the CPI in the current year, and then divide it by the CPI in the year contemporary to that amount of money, and that's going to give us our answer. Since 1964, the price level in the United States has increased by more than 10 times. And so 124 million back in 1964 is over $1.2 billion in today's money. We're going to copy this formula down, but before we do that, we're going to need to make one small adjustment here, which is to add a $sign in front of the row number for our current year, because we don't want Excel to adjust into the empty cells down below. Then I'm going to copy this formula all the way down, and we're going to get all of our numbers. Now we can actually compare these numbers to each other and think about, in terms of today's money, which of these movies had the highest revenue, which was Goldfinger. Even though in its contemporary year dollars, it made the least. But there's been so much inflation since 1964 that 124 million back then was quite a lot of money in today's terms. A box office of $1.26 billion would put a movie at number 3 in both 2023 and 2024, which gives you some idea for how much money this movie made. The last thing we're going to do in this video is to take a look at regional price parities. This is when we calculate CPI for a particular region within a country, such as a state. This table comes from a report from the Bureau of Economic Analysis that shows us the 2023 figures, which are the most recent ones we have available. If we look at this first column here, what it shows us is an RPP, or regional price parity, of 100 for the United States, meaning that 100 represents the national average. If we see an RPP under 100, for example, Alabama, that state has prices lower than the national average. Alabama's RPP is 90 in the all items category, meaning that overall prices are about 10% lower in Alabama than the national average. If we look at a place like the District of Columbia, Washington, D.C., the RPP is 110.8, meaning that prices there are about 10.8% higher than the national average, which makes sense because it is entirely an urban area. We can take a look at North Carolina here, which has an RPP of 94.1, meaning that prices are about 6% lower than the national average. The report also breaks things down into other categories, which includes goods, housing, and utilities. Housing tends to be a big driver of the difference in cost of living across different states, because it's relatively easy to go across state lines to buy goods, but it's not so easy to bring a house across state lines. We can look at a place like Colorado here that has an RPP in the housing category of about 130, meaning that their housing is 30% higher than the national average. So even though their utilities and goods are under the national average, this is going to push the overall RPP over 100. What these figures help us understand are the differences in the cost of living in different locations. This has been a quick introduction to the data and some applications that we can do with the CPI. If you have any questions, feel free to let me know. Thanks for watching.